Okay. Hi, children. So lesson 1.1, you've already copied down. I gave you the PDF in Canvas. Everyone should have had access to that. This is lesson 1.2. I understand. I'm not there. I'm coming back soon. Okay. Just be patient with me. I wish I could be there also. Trust me. I'd rather be there than here. Anyway. Okay. So let's, move on. So this is lesson 1.2. My goal, right, is for for everyone to watch this video so that when I come back, we can briefly go over both of them with A days, right? Or no, B days, sorry, B day, because B day hasn't gotten a lesson for me at all, right? So y'all have literally been on your own for like, this past week already. A day, fortunately, you got the first lesson from me, right? So you're going to have to do this lesson. Now, the reason I made a video is because if I give you a PDF, it's not as self-explanatory. It might actually even look more confusing than helpful, okay? So, yeah, make sure you watch this video through. I mean, if you feel like you're an expert at domain and range, just watch it. Okay, thank you. All right, so I'm going to go through all the examples, and I would appreciate it if when I ask for you to pause the video, you go on ahead and pause the video, do what I ask you to do, and then play the video and see if what you did was correct, right? Almost trying to mimic as much as if I was there in person, okay? So today we're going to be doing set and interval notation of domain and range. Hopefully y'all kind of remember what domain and range is. Really the only new part is the interval notation, okay, which really isn't that bad. Honestly, I think it's easier than inequality notation. So as a review, right? Okay, sorry. You're gonna need 2 highlighters, okay? So everyone has my buckets. Hopefully you're in my classroom and not in the auditorium. If you're in the auditorium, get to thinking, right? Maybe use a pencil and a pen, just 2 different colors, okay? But if you're in my room, I provided highlighters for you in the buckets. So y'all might have to share a little bit, right? So when I do domain, maybe you can switch with amongst y'all for the second color. Okay, figure it out. All right. Okay, so first of all, we know the inequality symbols, right? Less than or equal to, greater than or greater than or equal to, or greater than, okay? Now, we also hopefully remember the dots, right? So not inclusive means open, you can fall through it, it does not count. Or we have inclusive, right? Which is filled in, you can stand on it, so it counts. You include that part, okay? So now for the example, all right. The numbers on here, I know they're really hard to see, but they're basically going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it starts at 1. That very first dash is 1, and it's going. So I'm just going to circle the middle one for all of them. So we're going to circle 5. So there's open dot at 5, closed dot at 5, a closed dot again at 5, and then an open dot at 5. Right. So we know we're going to use the number 5 on all of these. So that stays consistent. So now what we're going to review is inequality set notation. This is what you did in Algebra 1, okay? And what you've been using since like the middle school. You're used to using the inequality symbols, okay? So for this first one, right? If it's less than, obviously the shading is going to go to the left because all the numbers to the left of the circled open dot are smaller, right? Less than. For the next one, again, it's less than or equal to. So we saw the closed dot and it's going to go to the left. And then on the third one, it's greater than or equal to. So it's closed dot and I'm going to highlight to the right. Okay. And on the last one, again, I'm going to go to the right because it's greater than. So those are the examples we're going to use for each one of these. Okay. So inequality set notation, I'm going to go over two ways you can write it when it's in inequality set notation, okay? One is including the infinities when it applies, and the other one is when you want to write it without the infinities, okay? So for this first one, obviously we already know this number. I am so sorry. This number is 5. I'm gonna write in pink, okay? This number is 5, right? We already know that, okay. So our values, we're gonna use n, okay? Remember, it can be any variable, any number, right? Our numbers, our values, our numbers, okay? Our numbers go from what to what? So we're putting those inequality symbols automatically because those mean in between, right? Your values are going to be bigger than whatever's on the left, and it's going to be smaller than whatever's on the right. Okay, so on the left side, what do we have? Well, you see an arrow, right? An arrow, well, what does an arrow mean? Where is it going towards? It's going towards negative infinity. So on the left side, I'm going to put a negative infinity because remember, we always write or we read it from left to right, okay? So on the left side, we can see it's going towards negative infinity and it goes all the way up until what? To that 5. Now at that 5, it's an open dot, so we know it is not equal, okay? So this is one way you can write that. So no equal to, right? So like we're done. Now, hopefully you remember in Algebra 1, if we would write it in inequality symbols, we would not use the infinity symbol with our answer, right? So the easy way to know what you're going to write without the infinity symbol, right? Or we're going to put or, all you have to do is look at the chunk without the infinity. So you see how I'm putting a box around that area? So that's exactly what I'm going to write down. N is less than 5. So that's the other way you could write it in inequality or set notate or inequality notation. Okay. Now set notation, just so you know, it's the same thing. It just has curly brackets. Okay. So if you looked at your answers, it would still pretty much look like this, right? But it would have curly brackets assigned to it. So that would be something like where n such that n is less than 5. So that is just another way. I mean, to me, that's self-explanatory, right? You still see what we just did in the answer. And if you have curly brackets, you're just being fancy. That's it. So for the rest of this, I'm not going to be writing it in that form because I feel like that's kind of self-explanatory. Okay. So for the next one, right, again, we're using the number 5. And we want to know, well, where do these values, what numbers are we using, right? So we're going to use n, and n is between, right? So n has to be bigger than the number on the left, but it has to be smaller than the number on the right. So we use the less than symbols, right, on both sides because that middle number, right, if you think about it and you think of your siblings, right, if you're the middle child, well, what does that mean? If you're in the middle, you're always going to be younger than the oldest, but you're older than the youngest, right? So that's what we're writing here. And that's why we always use those less than symbols, because the one on the left, you're saying that you're going to be older than the youngest, right? Because we go from least to greatest, and then, but you're going to be younger than the oldest, right? Okay, so on the left, again, we have negative infinity. So we're just going to put negative infinity because of that arrow, right? That arrow that I just circled right there, that means negative infinity. And on the right side, we still have that 5, but we have an inclusive dot. So that means we're going to have the equal to. So if I wanted to write it, right, without the infinity symbol, you're just going to grab this chunk and then you're going to write that n is less than or equal to 5. That would be your other way that you could write it in inequality notation. Then the next one, right? Same thing. We want to know where are our numbers? What numbers are we using, right? So on the left side, right, you're going to see that this time our dot is on the left. So this dot is number 5. So our 5 is going to go on the left, and on the right side, what do we see? We see an arrow. Then where does that arrow going to? It's going towards positive infinity because it's not going to stop. So we're going to put a infinity symbol on the right side. So remember, the other way you could write this is without the infinity symbol, right? So if you box this, right, you're always going to box your variable, the symbol you're using with the number you're using. Now, we like our variable to be on the left. So if I flip this n in that number, remember the crocodile has to stay eating the whatever it's eating, right? So you can see that the crocodile is eating the n. So you have to flip that symbol so that it still matches and it's still eating the n, right? So it's still an equivalent statement. Okay, so for this last one, again, we're looking at the values, and those values sit between what two things? Well, on the left side, again, you see that the dot comes first, and that's number 5. And on the right side, we have a positive infinity. So we're going to put that positive infinity on the right side. So if I wanted to write it the other way, remember, we're just going to box that part. And again, variable goes on the left, number on the right, and it's still eating the n. So it's going to go like that. Oh, I forgot the equal to over here. Sorry, you guys. Go on ahead and add that equal to, my bad. But there we go. All right. Now, that's an equality notation. So you should be somewhat familiarized with that from Algebra 1. Now we're going to do the new part, which is interval notation. This is what you haven't seen, but honestly, it's easier than inequality notation, in my opinion. Okay, so here it is. I'm going to use my highlighter, right, in yellow, because I'm not there, right? So bear with me. So y'all see this thing that I just highlighted in yellow, that negative infinity and this 5, right? I like interval notation because it's always going to be the same. So it's always going to be small, large, right? You're always going to put the smaller number first and then the bigger number second. It's always going to go in that order. You don't really have to, like, if infinity is involved, it doesn't matter. Negative infinity would still be your small. Positive infinity would always be your large. So if you have negative infinity, it's always going to go on the left. If you have positive infinity, that's obviously going to go on the right. Okay. And then also with interval notations, which I do give you down here, we, instead of equal to and not equal to and inequality symbols, we use parentheses and brackets. So we use parentheses and brackets, right? You use parentheses when you have an open dot, and you use brackets when you have a closed dot. Now, please keep in mind that there is a little teensy weensy typo on the notes. Oops, I'm sorry. So if these notes were printed before I fixed them, then right here where it says inclusive, you may have the wrong brackets. Okay, so make sure that your notes look like mine. Let me highlight it with green just so you can see it more, right? So make sure your brackets look like mine. So when it's inclusive, you should be using brackets and a closed dot and equal to symbols, right? So in green, I highlighted that. But if it's non-inclusive, which is in purple, right, you're going to use the no equal to. You're going to have to use parentheses. And we know that's an open dot, right? So please, please, everyone, make sure that that's written properly. If it's not, go on ahead and pause it and fix it now and make sure that it matches what you see on the screen. Okay, I'm assuming you paused it and now we're playing. Okay. So going back to interval notation, so my point is that it's really easy, okay? So what color do I want? Let's do blue. We haven't done blue. Okay, y'all see these yellow things that I highlighted, right? That negative, infinity, and 5. You're literally just gonna put that together with the comma and then with whatever needs to go around it. So I know it's negative infinity, comma 5. You're telling me it's going from negative infinity to 5. Now, Negative infinity is always going to be a parentheses because you can never actually include negative infinity. Remember, negative infinity isn't a number, it's a concept of numbers, right? You're saying that you're going to keep going forever and ever and ever, and you're never going to stop, and you're never actually going to get anywhere because you're going to keep going. And at the 5, because we have an open dot, we know we're never actually going to equal the 5. So that's also going to be a parentheses. And then that's it. That is interval notation. And why do I see it on my iPad but not on the screen? Okay, I'm not frozen, but my screen is for whatever reason. Okay,